Alright, chemistry. I was playing with some audio levels. Hopefully things don't sound super loud, but I also hope that I'm not super quiet. I'll try to check the playback. My mic settings have been off. I'll work on. I'll look at it. Very quickly. At time of recording, I have not finished grading the tests. However, the ones that I have graded, there's a whole big spectrum of scores, which is interesting. Because to my knowledge, I'm teaching the same class and all y'all are taking the same class, but I'm getting a wild spread on this test. Um, I know that the class is hard because I've taken chemistry. I've taken a lot of chemistry. I try to make it as straightforward and simple as possible. I've gotten a lot of emails, like, in response to test grades. At this point, there's very little that you can do other than continue to pay attention, continue to put the work in, continue to work with me, right? Maybe you need to ask more questions. Maybe it's, um, more clarification, doing more practice. It might feel like in the next few days you're going to get kind of slammed. I hesitate to use the word slammed. Like, it might feel like you're going to get more work from me. Um, I, I assure you it's like the same amount of work, but I do want to, I'll be checking in with you. I, it's a tough class, right? If you pay attention, you'll pass. Like, pay attention, be present, you'll pass. If you do the work, you'll do decently. If you do all the work and you're kind of conscientious about it, you'll do well. But it's difficult to do well. You have to put stuff in. I can't do most of it, and just anyway. I haven't graded them all. I am a little more than halfway through. I'm getting through them, and I will continue to kind of double check and vet things as I go along. But your test grades, again, are in the process of going up, and it's a bit of a mixed bag. We'll talk about that at a future date. A separate video will go up just dedicated to the test. What I want to do here, this is page 25. This is page 25. Right below me, right here, is page 26. Then there'll be some examples on page 27, which is a little further off screen. I want to finish this section. And when we finish this section, because it's the very end of a topic, I actually want to quiz just on this last bit of the topic, just on naming compounds. Now, what we have to finish here and here, these are the last set of what to do with ionic compounds. These guys down here are the notes on naming molecular or covalent compounds, and then there's practice that I'll have you do before your next day. Right, we're on F day, so the homework will be due for A day. Now, what this is, right, we had been doing, the practice that we did down here was going from the formula to the name. This describes how to go from the name back to the formula, right? So if you know the name of a compound, you can figure out what ions it's made of. And once you know what ions it's made of, you can make the actual formula, because we talked about this, right? If you know... Oh, just kidding. I went the wrong way. If you know what ions something is made up of, then you can create the chemical formula for it. So we'll do that. We're going to do that. When we do this, part of these notes are actually wrong, so I'm gonna write through the correct version of this. But if I have the... Oh my goodness. Okay, we're going to... How's that? We're going to look at that. We're going to look at this. Copper 2 sulfide. So copper 2 does actually mean copper with a charge of +2. So that ion is copper with a charge of +2. Sulfide, that IDE, means it came from the periodic table. It's sulfur, and if I check it, it has to be charged negatively. It's the second part, so it has to be negative. The only negative charge for sulfur is -2. And then what I do is I smash them together, and I play with the subscripts until they're balanced. In this case, I have a +2 and a -2. Just by smashing them together, I have a balanced and neutral compound. All right. What I'd like you to try to remember, right? First, this number tells you exactly the charge of this metal. And if it does not end in IDE, it's probably something that you need to find on table E. But I'd like you to, pause the video here, try those 3 and I'll go over the answers in a moment. I hope that you've tried them. I kind of stalled there. Hopefully you hit pause. If you hadn't hit pause, do those, because here come the answers. Alright, copper with a +2, because that's what this 2 means. This does not end in IDE, which means that this is very likely a polyatomic ion. It's SO4 with a -2 charge, which means I'm going to take them, I'm going to smash them together, I'm going to get CuSO4 copper 2 sulfate. Iron is Fe, it has a +3 charge. Bromide means bromine with a -1. When I put them together, I get FeBr3. If you remember the shortcut, that number goes there, this number goes here, and we call it a day. Now I had said when we did it that the shortcut worked 95% of the time. Here is the 5%. So if I take this and I put it there, and I take this and I put it there, what I end up with is SN2O4. However, you should see that these numbers can be reduced. If you use purely the shortcut, and if you get numbers that can be reduced, you need to remember to reduce them in order to get the correct formula, because SN2O4 is neutral. But structurally, I can't take 2 tins and 4 oxygens and smash them together and actually get a working compound. I need 1 tin and 2 oxygens, and I can put those together, and I can make something that works. But, bottom line, if you have a name, find the ions that make it up, take the ions and do just like we did before. Take the ions, put them together, either flip the numbers down, or do the quick calculation, how many of one do I need to balance out the other, and get the subscripts down there. Alright? That's the last bit of ionic compounds. Skipping ahead here, this is page 26 now. Page 26 has the rules for naming molecular or covalent compounds. It's important to remember that molecular compounds do not actually have charges. They're not made of ions, so they don't have real charges. They have apparent charges. They have charges that sort of almost pretend to exist. And strictly speaking, we call those oxidation states. So those numbers that are on the reference table, those are the oxidation states. That's why I said they're like potential charges. They could be. They kind of act like they have charges. We'll use prefixes for molecular compounds. So you know, oh, by the way, if you have an ionic compound, it will never have prefixes. But if you look at something like CO2, that's carbon dioxide. Di, like 2. Its cousin, CO, is carbon monoxide. Mono, like 1, right? So you have mono, di, tri. Those should all make sense. You should recognize penta like a pentagon, hexagon. It usually doesn't go much higher than that. This one is a bit funny, but if y'all have ever played Tetris, you should recognize that all the Tetris pieces are made up of 4 blocks, right? I could keep going, but tetra for 4 is like Tetris, right? All the Tetris pieces are made up of 4 blocks. So 4, think Tetris for tetra, right? Now, every atom, every element in a molecular compound gets a prefix unless the first number is 1. If the first number is 1, we don't bother with the mono, but every other time you're going to put all the numbers for all the prefixes. All the prefixes for all the numbers, sorry. Oh, goodness. I just realized that I shouldn't have done that. There we go. Okay. So down here at the bottom, there are 3 practice questions. I'd like you to actually add 1 more. So I'm going to go number 4. I want N2O5, and the reason for that is we've already done CO2. So, knowing that your prefixes have to exist, unless the first one is 1, in which case you just call it the element. But try those 4, well 3.5 I guess, but try those questions. Pause the video, try them. I'll go over the answer soon. Did you try them yet? Alright, here come the answers. S is sulfur, F is fluorine, but 6 is hexa, and you still change it to IDE, hexafluoride. This is carbon tetra chloride, right? Tetra for 4. Oop, just kidding. This is carbon dioxide. I also wanted to give you this because it's not something with a 1, so it's dinitrogen pentaoxide. I've seen pentaoxide. I feel like I've also seen pentoxide. I wouldn't take off for either. I recognize exactly what you're trying to do. Saying it sounds like pentoxide. So it sounds like the bottom one, but I think it's spelled the top one. I would have to like triple check that. In any case, what I'd like you to do as practice is right up here. It's on page 27, right? It's the top half, just 1 through 10, going from the formula to the name. Also, label as ionic or covalent / molecular, right? You can use either, be consistent, but because we have different naming conventions, you need to identify it first, and then you can name it, right? So identify, maybe just like over here off in the margin, right? Identify whether it's ionic or covalent, then name the compound, right? I'll go over this first thing on 8A, and keep your eyes open for the test answer explanations to go up in the quizzes and tests assessment. I don't know. I don't remember what topic it is, but I think it's called quizzes and tests. Check for it there. Until the next time, all right? I will see you. Take care of yourselves.